Okay, so the recording has already started, so let's dive into today's lecture. Now, what we're gonna do today is we are going to continue our discussion on, data visualization techniques. So much of the concepts that we are going to cover today is something that you probably already have done in statistics course. But then again, these concepts will be extremely important in, machine learning, and therefore we will just look into these things very quickly. Okay, so in the next couple of lectures we will look into many of the concepts that you may have seen in statistics courses. Okay, all right, but we will not I'm not going to do right now is I'm not going to go into the details of the statistics. We're going to look into certain things that are for machine learning purposes, certain things that are going to be important. Okay, so I'm just going to cover those things very quickly. Okay, all right. So okay, so if we get started, let's get started. Okay, all right. So with the Python code. All right. So okay. So ready? Everyone can see my screen. Yeah. Can you guys see my screen properly?
Yes, sir.
Okay.
Yes, sir.
So what I would recommend you guys is I would recommend you to actually try these codes alongside as well. Try these codes, and there are different variations you can also do. Okay. So I would highly recommend you. Okay. Try this now, or maybe it's a good idea to actually, look at this video again and then try this sort of codes, in Jupyter Notebook. In addition to that, what else can you do is you can also do some changes, okay, and experiment with these changes and see what really happens. Okay, so let's get started. So we are going to discuss data visualization techniques. So you know what you have is in machine learning, once you have a data set, it's a very good thing that before you start applying any kind of machine learning, it's a good thing to have a good understanding of your data set. Okay, all right, because once you have a data set, there could be lots of issues about the data set, and you may have to deal with these issues. There might be outliers, there might be other things. Okay, so what is required is once you have your data set, don't just start applying machine learning. Okay, have a look at the data set, understand the data set a little bit. Now, one of the ways you can understand the data set well is to visualize them. Okay, and what happens is when you have done statistics courses, yeah, I'm sure you guys have done statistics courses, right? Koran na? Have you guys done Math 361?
Yes, sir.
Yes,
So
sir.
you guys have done statistics courses. Also, you may have done statistics courses before coming to universities, right? Yeah, you guys probably have done statistics before, maybe.
Yes, sir.
Okay. In statistics courses, you may have seen different kinds of graphs. You may have drawn a histogram, probably, right? Maybe you have drawn that. Maybe you have drawn something like a bar chart, or maybe you have done something else, other plots as well. Like for example, I don't know, have you done anything like a box plot? Did you ever draw a box plot before?
Yes,
Anybody?
sir.
Okay, right. Box plot কোথায় করেছেন?
Sir,
When
I did it way back during my A levels.
ওকে, আচ্ছা, বাকিরা কি কেউ কখনো বক্স প্লটের নাম শুনেছেন? No. Okay, no problem. So there are different kinds of plots available: box plot, Violin plot, okay, KD plot, okay, and এক একটা plots এক এক ধরনের ডেটার জন্য they are I would say suitable, and what they really help you to see is to really help you to understand the data set well. Yeah, so we're going to cover certain popular kinds of plots that we can draw, and we can also look into like where these plots would be useful, okay, when you have the data set, okay, so that you have a good understanding about the data set itself. Okay, so in any case, let's get started. So the first thing that we are doing over here, we are importing over here. If you can see over here, I'm importing two libraries here, two things over here. Number one, we are importing something called PyPlot from the Matplotlib library. Okay, is a PyPlot package. So I'm importing that from the matplotlib library. So the command for that is you can write from matplotlib import pyplot as plt. So we are giving an alias name to pyplot. So instead of every time calling it as pyplot, I can call it plt. Is this clear, Nakina? Yes? Are we good?
Yes.
Yes,
Or
sir.
you could also write this as, I guess, from matplotlib.pyplot as, these commands can be written in many ways. Okay, so this is one of the ways. So from matplotlib import pyplot as plt. And then we're going to use another library. Okay, so we spoke about that in the last class. This library is called Seaborn. So matplotlib and Seaborn, they are basically used for data visualization. So these libraries are very useful for data visualization. And turns out that we are going to use both the libraries together. In fact, Seaborn is created as a wrapper over matplotlib. So on the top of the matplotlib. So there are many things Seaborn actually can do to the matplotlib. So we'll see some examples. So let's just go ahead and actually run this cell. So if we run this cell, it's running. Okay, and there is no error. So right now we have imported both pyplot from matplotlib, and we have also imported Seaborn. Okay, now let me show you, as I was saying, that Seaborn can make certain changes to, like Seaborn can work with matplotlib. How does it do that? How Seaborn can update matplotlib? So let's have a look at these things. Okay. So one of the ways Seaborn can do change matplotlib is it can update matplotlib's RC parameters. Now, what does RC parameters mean? RC parameters stands for the run commands parameters. Okay, so Seaborn can change the matplotlib's RC parameters or run command parameters. Now, what are run command parameters? যখন একটা command run করছো, there are a lot of parameters to that. যেগুলো হয়তো you're not even setting them, but default setting হয়ে যাচ্ছে, তাই না? So what Seaborn does, it can actually change those settings a little bit so that your graph or your plots, they look a little bit better. So to improve the aesthetics, I'll give an example. Okay. So here's an example that I gave you earlier in the last class, perhaps. Okay. Imagine we have got two lists here, X and Y. X contains the values 10, 20, 30, and 40, and Y contains the values 0, 15, 10, and 25. Is that okay? Okay, now. Are we good?
Yes.
Yeah. So this is it. Awesome. Now look at this in line 3. I'm saying plt.plot xy. So if I say plt.plot xy, তার মানে এটা আমি কোন library কি use করছি? Am I using matplotlib or am I using Seaborn?
Matplotlib.
Matplotlib. How do you know that?
Matplotlib সংক্ষিপ্ত রূপ PLT হিসেবে ডিফাইন করা হয়েছে।
Matplotlib না pyplot এর হচ্ছে PLT, right? Okay, that comes from matplotlib package. So if you just say plt.plot xy, you should be able to see a graph for x against y, right? X is plotted on the x-axis, y is plotted on the y-axis. Of course, if you want to give a title, if you want to give a label to the x, label to the y, you can do all those things that we have shown in the we have shown those things in the last class, right? Is that okay?
Yes, sir.
Okay. Now look at this, something that we're doing over here. I'm now writing a small command called sns.set. Okay. Now if we put sns.set, and now if we call again that plt.plot xy, this time you again get a graph, but can you see that this graph is a little bit different now from the previous one? In terms of aesthetics, it's the same graph, but in terms of its looks, it's a little bit different. It now has grids, okay? Its background color is slightly different. Can you see that, Nakina? Yeah? Yes?
Yes, sir.
Okay, so what really happened is whenever you invoke this command set, okay, in the SNS library, sns.set, what it did is a plt.plot যখন plot করছো, okay, এখানে অনেক parameters আছে, যে parameters গুলো you are not setting it over here, but what the Seaborn does, it sets those parameters up, and that's why it looks a little bit different. Okay, right? Man, the graph is fine, it's just the aesthetics looks a little bit different. So let me show you what really happens. So Seaborn is set, use করছি. So let's just have a look. So one good way to see this is always to actually, search. So I mean, you like Seaborn set. So I just want to see what happens when I use the Seaborn set function over there. So just click on that. Take a second, go to the documentation. And if you go to the documentation, you see that cbound.set, it's an alias for another function called set underscore theme. So that's what it does. If you go there, so it does certain thing. That whenever you say cbound.set, it actually initializes something called context as notebook. It initializes style as dark grid. Okay, and because you can now see the style is dark grid, that's why you had a dark grid over here. You've got greens over here, right? And it's dark, right? Yeah. And then it set the palette as deep. Now what's a palette? We will see that. It's set the font to sans serif and font scale to 1. So did you see that it actually changed certain things over here that is going to change the look of this plot that you're making? Clear, Nakina? Is that okay? Yeah.
Yes.
Yes,
Is
sir.
that okay? So that's the reason why your plot now looks like a little bit different. But what really has happened is that the Seaborn set actually now changes these properties in the Matplotlib library, and that's why I was saying over here that you can use the Seaborn to actually update Matplotlib. That means it can update the Matplotlib's run commands. Okay, that is usually used to improve the aesthetics. Okay, clear, Nakina? Is that okay? Understandable? Yeah. Now you can always do different.
Elaborate করবেন
Key elaborate জানতে চাও তুমি? What is the thing that you want to know?
So it said the context needs string or dict. We didn't provide a string or dict, but it
No, we
considered
did it.
something.
Yes,
So
because whenever you said set, okay, all right, whenever you said set, there are different kinds of strings that can be put. So you can actually click on that and go deep into the documentation and see what are the different values that you can put over here. Is that clear, Nakina? Yes. But when you did not put anything, when you just put set, it initialized the context to notebook. Can you see that over there? That's the default values. Okay, right? But you can then click on these and go deep, and you can change these things, and it will be a little bit different. So for example, style is dark gray. Okay, automatically default parameter is dark gray. But if you want to see other styles, you can just click on that, and then you can look at set styles, key values are set. Okay, so you can look at a dark grid, white grid, dark. So there are different kinds of options that are available. Okay, but the default option was dark grid. Clear? But আমি যদি চেঞ্জ করতে চাই এখানে সেট, তাহলে প্যারামিটারে গিয়ে স্টাইল ইকুয়ালস টু ডার্ক গ্রিড না করে যদি হোয়াইট গ্রিড বলতে চাই, then it will look a little bit different. ঠিক আছে? So similarly over here, you can just go over here and look at what are the options you have. Like the options are paper, notebook, talk, poster, what kind of মানে কিছু জন্য সুটেবল হয়। এটা আমরা এখানে নোটবুকে কাজ করছি, জুপিটার নোটবুকে। So we set the context as notebook. Is that clear, Nakina? Yes. Okay, but
Yes, sir.
you can actually play with these things by changing these values, by changing these variables. So context is notebook, not did to context equals to the paper. Let's do that and see what happens. Okay, all right. Palette is deep. So what are the different palettes that are possible? So if you can go over here, so palette is deep. So you can actually look into it. Palette নিয়ে আমরা আজকে আর further কথা বলবো, different kinds of palettes that you can use. So you see that instead of deep, you can use other palettes as well. Like you can use the palette like pastel, set2, ঠিক আছে? And there are many kinds of palette. ঠিক আছে? So you can change these things, and it would look a little bit different. Is that clear? Understandable? Yes.
yes,
Yes, sir.
now it's
Right.
understandable.
Okay, so that's what really has happened over here. Okay. So that's just to show that Seaborn and Matplotlib can sometimes go hand in hand. Okay, and you can use Seaborn to update the look of it by invoking the set. If you want to give a different context, so you can give a different context. So for example, if I want to give, I don't know, context equals to paper, I don't know, this would not change a lot here right now. Okay? So if we go ahead, okay, so I set the context as where is it? Did I do that? A paper, but it did not really have much changes in the look. ঠিক আছে, এই ইয়েতে খুব একটা changes আসে না। But আমি যদি অন্য কোনো প্যারামিটার চেঞ্জ করি, for example, if I change the style যদি dark grid না দিয়ে আমি যদি অন্য কিছু দিই, ঠিক আছে, for example, what are the different styles over here? Dark grid হতে পারে dark. I can give the style as dark. So I can just come over here and say, okay, the style, let's change it to and then plot it. So you see the grids are wrong. Can you see that, Nakina? Yeah?
Yes, sir.
Hello? This is how you can actually play with this one and change different parameters to see how does it look like. Okay. When you do dark na do the white daw, so that would look like, I think, the original one. But let's see. When you do white thing, okay, it looks like the original one that we have. মানে অরিজিনালি ম্যাটপ্লটলিব যেটা ছিল, ঠিক, ওয়েল এটা ছিল ম্যাটপ্লটলিব, রাইট নাকি? ইয়া, ঠিক আছে। Okay, so sorry, white দিলে just it's white, there is no grid over there. আমি যদি এটাকে আবার চেঞ্জ করি, I think white grid is one of the options, is it? Yeah, so it's white background and grid, there are grids as well. So this gives you a lot of options to change the style of how you want the plot to look like. Is that okay? Does it make sense, Nakida? Yeah? Is that okay? All right. Acha, the next thing that we're going to discuss, as I was saying, that we can do different kinds of plots. Okay, I can draw a histogram if I like. I can draw a scatter plot if I like, and things like that. Okay. Now there is a plot that I'm going to start our discussion with, and this plot is called the KDE plot, or it's called the kernel density estimation plot. Have you ever heard of this plot before? Kernel density estimation?
No, sir.
No. So let's have a look. What is a kernel density estimation plot? Okay, and how does it? What does it do really? Okay. So I'm not going to go into the details of the statistics, but I'm going to give you good enough background to what does this kernel density estimation really mean. Because you guys all have done statistics, all of you have done statistics. এমন কি কেউ আছে যে কখনো কোনো ধরনের statistics কোর্সই করে নাই? Is there anyone who never has done any statistics course here? Okay, so all of you have done statistics courses, so you have a little background on statistics. Am I right, Nakina? Is that okay? That's something, a fair thing to assume? Yes? Okay, so if that's a fair thing to assume, so let's look at what's a kernel density estimation plot. Okay. Now, do you understand what is a frequency distribution? Do you understand what's a probability distribution or frequency distribution? এগুলা সম্পর্কে idea আছে? What's a frequency distribution and things like that? So when you have a kind of, let's say, for example, you've heard of normal distribution? Nakina? Yes,
sir.
Right. You guys have definitely heard of normal distribution. So that's a popular distribution many of you may have heard of. So if we look at this, how a normal distribution typically looks like, it typically looks like this is the kind of graph that you typically get. Okay. So here's this one. So I'll not be very good at drawing it, but let's try it. Okay. So it's like this, where some sort of, I'm sorry, this diagram is not so good, but you understand the point. So you get some sort of bell-shaped graph, right? Clear? Is that right? Yes?
Yes.
So what does this graph show or indicate? What does this graph indicate me? Any idea? So what do we have on the y-axis? What do we have on the x-axis? X-axis, you just have the data, right? Yes? Y-axis, you can plot different things. You can plot a frequency. That means you can plot frequency or you can plot other frequency density sometimes, ঠিক আছে, frequency অথবা some people also plot something called frequency density. They would look similar in shape but different scale হবে, ঠিক আছে, but that's what we plot. Now what does it mean? Sometimes a particular data corresponding value হচ্ছে এইটা, right? So what if I plot a frequency graph, what does that mean? তার মানে এই ডেটাটা has come this many times, has appeared this many times, right? Nakina, something like that. Clear? Yes?
Yes, sir.
আচ্ছা, because এই ক্ষেত্রে আসলে ফ্রিকোয়েন্সি বা ফ্রিকোয়েন্সি ডেন্সিটি নাও করে অনেক সময় প্রবাবিলিটি করব, because this is a continuous variable, ঠিক আছে, so we also draw probability. So it says this এই ডেটাটা এরকম ডেটা আসার probability কত, ঠিক আছে, if the data follows this normal distribution of this particular distribution, a particular data or probability কত, clear না কিনা, something like that. So it sometimes also can be called as a probability distribution. So you have an understanding of the kind of data that you have, clear na kina, is that okay? Now distribution is very important. It's very important to see what kind of distribution that you have in a data set. So you have collected some data, and what's the distribution of data? It's sometimes very useful concept, okay? Now interestingly, what we now have is we collect some data sets. So we have some data. Now we want to use this data to find or estimate the distribution of the data. Am I correct, Nikita? Clear? Yes? Okay. So from the data, we want to see what kind of distribution does this data have. Is that okay? One of the ways to do that is using the KDE plot. So we can use something called KDE plot to actually find out the distribution of the data. What does KDE stands for? It stands for kernel density estimation. So it actually estimates the distribution of that. So let me just walk you through how does this KDE work. Now this is something, it's a resource available, but I'm not going to go through this entire thing. I'll just look into some of the slides over here. So this is something I have actually found in internet. It's a very good resource, but I'm just going to go through the first few slides just to show you what does the kernel density estimation do. Is that okay? So once you have a good understanding of what kernel density estimation do, then we can just see how we can actually create a kernel density estimation for a data set. Okay, all right. So can you guys see the screen, Nakina? Are we okay?
Yes, sir.
Yes,
Okay.
sir.
So what is the kernel density estimation? Okay. In a kernel density estimation, what we do is we have some data points. So let's say 1, 2, 3, 4, 5. Just for the sake of saying, we have 5 data points. Okay. আচ্ছা, এই ডেটা পয়েন্টস গুলোকে আমরা এখন ইউনিভ্যারিয়েট ডেটা পয়েন্টস বলছি। ইউনিভ্যারিয়েট মানে কি? Just one variable. Okay. Multiple variables, not just একটা ভেরিয়েবলের data points, ঠিক আছে? So how many data points do we have now? Sorry. How many data points do we have now over here? 5. So we just place them, okay? A data point হচ্ছে AX value জন্য, so we place it over here. A data point X value এটা, 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 ঠিক আছে? Is that okay, নাকি না? Are we good?
Yes, sir.
আচ্ছা, so what we do on a kernel density estimate, from these data points, we want to find out what kind of distribution we have. Okay, we want to create an estimation of the distribution. So this is what the idea of the kernel density estimate. On every data point that we have xi, so there are 5 data points in this example. So for every data point xi, we place a kernel function k. So here's the kernel function k. So we place a kernel function k on every data point we have. ঠিক আছে? আচ্ছা, now what is this kernel function? A kernel function can be anything, like there could be many examples of kernel function. Let's say I can have this as a kernel function. Sorry, okay, this would be a Gaussian kernel function. If you want a triangular kernel functions, I can plot a triangle. ঠিক আছে? So on every data point, or there are many other options we can do. So what we're going to do is on every data point, where am I? Okay. On every data point, we are going to actually place a kernel function on kernel functions, right? Okay, now, okay. So what happens then? So if we place kernel function k on every data point, okay, that's what we're going to do. So that's the first thing. Then the kernel density estimate is given by this equation. So have a look at this one. What does the kernel density estimation do? So k, so on every data point xi, I'm going to apply this kernel function, whatever the kernel function may. It might be a Gaussian function, it might be a, you know, triangular shape, or other functions that are available. And then we're going to sum it up. প্রত্যেকটার উপর এই পাঁচটা data point উপর পাঁচটা kernel function যখন apply করব, we can sum it up, and once we sum it up, we get an estimation of the distribution. So let me show you an example. So that's the first data point. If we apply a kernel function on that, that's it. So this is the Gaussian one. Did you see that we applied a Gaussian kernel function on this one? So a data point যেখানে we have the highest probability here. Okay, the probability diminishes as you go away from the data point on the left as well as on the right. Is that okay, Nakina? ঠিক আছে?
Yes, sir.
So we apply the kernel function on these data points. So similarly, I'm going to apply the kernel function on every data point. So if we apply the kernel function on the second data point, that's what it's going to look like, right, Nakina? That's for the second data point, correct? Yes?
Yes, sir.
That's for the third data point, that's for the fourth data point, and that's for the fifth data point. Does it make sense, Nakina? Yeah? So we apply this kernel function on each data point. So on this data point, that's the kernel function. That's the Gaussian kernel that we apply. On this data point, this is the Gaussian kernel that we apply. On this data point, this is the Gaussian kernel that we apply. On this data point, this is the Gaussian kernel that we apply. And in this data point, this is the Gaussian kernel that we apply. Clear, Anakira? Is that okay? Yeah? ঠিক আছে? Okay. Now, once we apply this kernel function, which is given by this equation, k of x minus xi, then we're going to sum it up. Sigma equals to 1 to n. যতগুলো data point আছে, we're going to sum it up. So if we sum it up, what happens? So a kernel এবং এই kernel যদি আমি sum up করি, then you see it changes a little bit. Can you see that? এখানে এইটার value আর এইটার value, they will add up, so it will go up a little bit. Can you see that? নাকি না? Clear?
Yes, sir.
So similarly, if we start adding all the kernels, right, this is the final distribution that we end up getting for these data points. Is that okay, Nakina? Clear?
Yes, sir.
That's basically how does the kernel density estimation work. So from the data points, it finds out the distribution of the data. That's what we have. And we can see over here, we have a bigger, we have a higher probability, means more data points are on this side. And you can see the more data points are on this side. And you can see there are some data points here, there are some data points here, but here the data point will be more, right? Okay, now we can see this sense, okay? Now, then the question is, এই যে kernel function টা যে apply করলাম, okay, can it be only Gaussian? Can it not be something else? It can be other kernels as well, okay? So the kernel function that we typically apply has three properties. Number one, it must be a non-negative one. So the kernel function cannot have a negative value. Negative value হতে কি এটাকে reduce করে দিবে. That's what we not want to do. We want to add it up, right? So the kernel function should have a positive value or zero value. ঠিক আছে? But it cannot have negative values. The kernel function should be symmetric. So you see, as you go, if you draw a vertical line here, as you go to the left or to the right, okay, it's symmetric. Okay? Clear? And the third one is, it must be decreasing. So যেখানে তোমার data point আছে, we have the highest one. As you go away from that, the kernel value is decreasing. As you go away on this side as well, the kernel value is decreasing. Clear? So this was the Gaussian kernels that we had. We could have other kernels like box. So this is like a box. So this is the data point. You draw a box, and then it becomes 0 on this side and 0 on this side. Triangle, right? That's another one. Okay, tri-weight. And people, actually, those who are in statistics, they actually try out with different kernels and see what kind of density estimation that it does. Okay, yes. So if we are trying to do apply, let's say the triangular kernel on the same data points. So let's see what happens. So this is the data point. So let's apply a triangular kernel. So this is the triangular kernel. Okay, second one, this is the triangular kernel, triangular kernel, triangular kernel, triangular kernel. And then you simply add them up. So if you add them up, this one and this one, it changes a little bit, little bit, little bit, little bit. So this is the kind of distribution you end up having. Now, one thing you might say, Jay, it's the same data point, right? But since I have chosen a triangular kernel, do I not get a little bit different kind of distribution than if I have used, Gaussian kernel, right? Clear? We get a different kind of distribution, but it's the same data points. Okay. The reason for that is actually it doesn't matter what kind of kernel you use. You can use any of the kernels. As long as you have a lot of data points, you will end up having almost similar distribution. Is that clear, Nakana? Yes. But over here, I have used very few data points just to illustrate the concept. There are 5 data points over here. So that's why you see a little bit different distribution if I choose a different kernel. Am I clear, Nakana? Is that okay? But instead of 5 data points, if I had 500 data points, it really wouldn't have mattered whether you use a triangular kernel or you would have used, a Gaussian kernel or box kernel. Doesn't matter. You'd get almost similar, and similar distribution. Is this clear, Nakida? Did you understand? So far good?
Yes, sir.
Okay, so I think this is a good enough introduction to what is a kernel density estimation, and there's a lot of things like choice of bandwidth and stuff like that. Because these things are something like this. Like for example, when I'm using Gaussian, okay, all right. Like for example, we apply the Gaussian kernel. Now, why did I choose a Gaussian kernel with this width? Can I not change the width of that? Okay, if I change the width of that. Okay, if I use a narrow width kernel, would it actually have an impact? Now, there are a lot of things that we can experiment on, but that's something we're not going to look into right now. But do we now understand what does a KDE or a kernel density estimation do? Yeah. The main purpose of a kernel density estimation is once you have a data point or data set, it uses that data set to understand what kind of distribution does it have. Okay, it estimates the distribution of that. Clear? Is that okay, Nakina? Hello?
Yes.
Clear? Now, with this introduction, I can go on more on kernel density estimation and talk about that, but I don't want to turn my, course into a statistics course. So we just use the basic understandings from there, and then we're going to see what different things that we can do with that. Okay. So let's start with kernel density estimation plot. I'm going to show you something called a univariate kernel density estimation plot. Univariate would mean we have one variable. Okay, so we're not looking into multiple variables. Also, although we can do that. Okay, maybe I'll show you later on multiple or just called bivariate KDE plot. We can look at that later. So let's use a data set that's already there. And upon the install correspondent, there's a lot of data sets we have. So I'm going to just use one data set that's already there. So if I invoke this command, sns.get dataset names. So these are the different data set that we have, right? So let's just first of all try this data set called MPG. Now this is a data set on cars. So we're going to load this data set. So the way we load this data set is this one. sns.load_dataset, and we are giving the name of the dataset. The dataset is called MPG, right? And then we take the dataset, and then I invoke .dropNA. I could have done later on, but I'm doing it together in one line. So .dropNA. What does .dropNA do? Anybody?
Sir, একটা
drop the tables
row
that
or
are-
column কে drop করবে।
No. Drop NA, if there are some data points you have missing entries, that means there are no values available there. ওই data points এর row গুলোকে শুধু drop করছে। Clear? Column গুলোকে drop করতে হলে I have to change the axis parameters. আমি হয়তো last class বলেছিলাম একটু, তাই না? Because I did not give in the axis parameters. So তুমি drop in দেখলে বুঝবা যে if you go to the library, you'll see that it's going to drop those rows. Is that okay, Nakina? Are we good? Yes? So far so good? So what did we do? We took this data set called MPG, okay? And we dropped those rows or those instances where there is some missing entries. Is that okay, Nakina? Clear? ঠিক আছে? আচ্ছা, এবং এটাকে নিয়ে I am storing them in cars. So what is this cars over here? What is this one? এই কার্সটা কি হবে? I'm storing them in cars. So what is this cars? Can you tell me? This is
data
a
frame.
Yes, this cars is the pandas data frame. Cars here is the pandas data frame. So that's what happens. So basically, SNSD, when you load the data set, it actually returns the data frame. So you can store the data frame in cars. But I have dropped it and stored this in the cars. Is this clear, Nakina? Yes. And just to have a good sense of what kind of what's the shape of this data, I applied cars.shape. If I say cars.shape, I see that there are 392 rows and 9 columns there. Okay, so there are 392 instances and 9 columns. In order to just have a better understanding of what different kinds of data we have, so I just I invoke this command cars.head. Cars is the data frame .head. So when I say .head, what it does it do? কি করে সে? First 5 instances কে সে print করে। Now আপনি যদি first 5 instance না করে first 10 instance করতে হয়, it's 10 over here. That should be good enough. So 10 দিলাম, see there are first 10 instances over here. Our default value is 5. Correct, Nakina? Is that clear so far?
Yes, sir.
Are we good?
Yes, sir.
So now একটু ভালো করে দেখি। So first 10 rows, what are the values that we have? Now first of all, what are the attributes we have? The attributes as MPG. MPG stands for mile per gallons. How many miles does this car go per gallon? How many cylinders does this car have? Okay. Displacement, how much perhaps it travels. Horsepower কত, weight কত, acceleration, model year, কোন ইয়ারের মডেল, ঠিক আছে, এবং origin, এটা কোন দেশের, ঠিক আছে, okay. Right now, first time আমি সবাই দেখছি USA, but maybe I think there are different other origins as well. We'll see that, ঠিক আছে, okay. We also have a name for that car. So, for example, this one is Plymouth Satellite, ঠিক আছে. This is for Torino, okay, and so on. So these are the different names that we have for these cars. Are we good enough? So do we have a better understanding of this data set? Nakina, the data set মধ্যে কি কি আছে? Is that clear, Nakina? Yeah.
Yes.
Okay. Now, if you count the number of columns, so you have how many columns? 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that's exactly what is returned when we invoke the shape, okay, function of the cars. ঠিক আছে, over here, data frame, pandas data frame. So cars dot shape যখন দিয়েছে 392 instances and 9 columns. So you see these are the 9 columns that we have. Is that good enough, Nakina? Clear? Good? Awesome. Now, let's say we are interested in one of these, attributes that we have. Let's say we are interested in horsepower. Okay, that's a very interesting thing. So we want to look into horsepower. So is it, first of all, discrete or continuous? What do you think? Is it discrete or continuous? Hello?
So it's
Discrete. Okay. Why do you think it's discrete? What's the difference between discrete and continuous?
স্যার কন্টিনিউয়াস একটা রেঞ্জের মধ্যে সবগুলো মানে গ্যাপ থাকবে না, সব যে কোনো ভ্যালু থাকবে আর কি।
আর
ডিসক্রিটে
এটা তো কন্টিনিউয়াস ডেটা হবে।
discrete কি? তাহলে what is discrete then?
স্যার নির্দিষ্ট ভ্যালু লাইক 1 2 1 and 2 এর মধ্যে অন্য কিছু হবে না,
Right.
either 1
So
হবে
you
or
have
2
some discrete values, right, Nakeda? You cannot have any values. Like horsepower ki discrete হবে. Can you have নির্দিষ্ট horsepower? Nakeda can have any values of horsepower over here. What do you think?
স্যার any value?
Yeah, so it looks like more continuous then, Nakeda.
Yes.
Yes. Okay. Now, আরেকটু বেটার বোঝার জন্য আমি আরেকটা জিনিস করতে পারি, সেটা হচ্ছে I can find out how many unique values of horsepower are there. I can actually figure this out. How many unique values of horsepower are there? ঠিক আছে? Okay, right? We can do that. How many unique values of cylinders we have? We can do that. So we can look at all these things. ঠিক আছে? Okay. আচ্ছা, just so that যেহেতু একটু কনফিউশন হচ্ছে যে হর্স পাওয়ারটা কি ডিসক্রিট না কন্টিনিউয়াস, আমি maybe later on I'm going to show you another piece of code that you can use to do a lot of very interesting things. But right now let me do one thing. Okay, if I say the data frame is called cars, right, and we are interested in horsepower, right? Horsepower, right? Is that the spelling? Horsepower. Because a dot. Okay, how do you find unique how do you find what are the different values that you have? Yeah, I think there is a command called value counts, right, Nakina? That's it. If we do value counts, can you see that it goes on and on and on? Can you see that, Nakina? Yes, right?
Yes, sir.
So how many unique values can you see over here? 93 unique values. Can you see that, Nakina? Yes, the length of this is 93, correct? So
Yes, sir.
this is probably not discrete. ঠিক আছে? For example, আমি যদি cylinders দেখি এখানে কতগুলো cylinders আছে, that might be discrete. So if I, instead of horsepower, if I change it to cylinders, let's say, and then run this, now we can see we can have only how many cylinders value. I can have a car with a cylinder value 4, car with a cylinder value of 8, 6, 3, and 5. Clear, Nakina? So this is discrete. So there are 199 cars over here in this data set with the 4 cylinders. Okay, 103 data points with 8 cylinders, 83 data points with 6 cylinders, 4 data points with 3 cylinders, and 3 data points with 5 cylinders. Right, Nakina? Clear? Is that fine?
স্যার আমার কোশ্চেন আছে একটা
Deep.
স্যার হর্স পাওয়ারে আমরা ক্লিয়ারলি দেখতে পাচ্ছি যে ওখানে একটা ফ্লোটিং ভ্যালু আছে 440.0 এরকম কিছু, বাট সেখানে ডি টাইপ দেখাচ্ছে ইন 64। ইজ ইট কারেক্ট অর লাইক কোনো ইস্যু আছে এখানে?
না না না, ওটা ডোন্ট ওয়ারি অ্যাবাউট দ্যাট। ঠিক আছে, এটা 0.0 বিকজ মেবি দেয়ার ইজ নাথিং ইন দ্যাট পয়েন্টের পর 3 4 এসব কিছু নাই দেখে it actually figured it out. This is really floating. The point আছে কি it's like that. ঠিক আছে, দেখি তো একটু horsepower, তাই তো? Let's have a look what happened. Horsepower, right? Okay, let's have a look. This is what you're saying, that the data type you're seeing is int, although there is .0. ঠিক আছে, because it actually didn't find any floating points here. তার জন্য সে actually print করে এটাকে integer বলতেছে। ঠিক আছে, but that's okay. All right, are we good? Is that fine?
Yes, sir.
ঠিক আছে?
Yes,
Okay.
yes.
So we are good enough to understand that cylinders over here is discrete, but horsepower over here is not discrete really. It's actually continuous because there are a lot of values over here, right? I mean, it can have any value within this given range. ঠিক আছে? Clear? Is that okay? Are we good so far?
Yes, sir.
Now let's say I want to know what is the distribution of this horsepower. এই যে horsepower যে attribute আছে, এটা distribution আমি জানতে চাই। ঠিক আছে? Okay, so what can we do now? So this is a continuous variable, so we want to know the distribution of that. So we want to estimate the distribution. So that's one thing where you have the KDE plot. So we can apply this KDE plot to actually estimate the distribution. So what I can do, I can invoke the KDE plot, sns.kde plot, right? Seaborn's KDE plot. So I say Seaborn's alias is SNS, so I can write sns.kde plot. Now KDE plot, I mean car KDE plot জানতে চাচ্ছি horsepower. Is that right, Nakina? Yes. So we actually put all the horsepower data on x-axis, so x equals to horsepower. And where am I taking this horsepower from? From the data frame called cars. So it must say data equals cars. Is that okay, Nakina? Clear? Yes.
Yes, sir.
So if we run this one, so you see we get a distribution like that, right? So this tells me a kind of distribution that we have. Now জিনিসটা হচ্ছে না, আমরা যখন একটা গ্রাফ প্লট করি, এটা এমন না যে একটা প্লট করলাম, দ্যাটস ইট, প্লট করলাম শেষ। ঠিক আছে? নাও দ্য প্লট থেকে what can you infer from here? That's important. ঠিক আছে? আচ্ছা, তাহলে আমাকে বলেন তো maximum horsepower মানে maximum horsepower মানে হচ্ছে not maximum value. What I'm trying to say is that most cars have what horsepower? কোন horsepowerটা সবচেয়ে common? এই যেটা. This is the highest density, right? So that would be somewhere around, I think, 80 or something like that, right? Yes?
Yes, sir.
Yeah, and minimum horsepower is this, maximum is this. Okay, I can find a little bit of summary statistics for horsepower as well. I can do that. How can we find the summary statistics for horsepower? So one of the things that I can do is, let me actually create a new cell below that. Okay, Acha, what's the name of the data frame that contains this horsepower? What's the name of the data frame?
Cars.
Cars. So let me write cars, and I'm just interested in the horsepower. So I'm not interested in all the attributes. So let's write the horsepower, right? Cars horsepower. Okay. Dot describe. If I don't know if I can do this way. That describe. If I do that, yeah. So it now gives me a summary statistics. So what does it give me? It gives me a summary statistics. Right, okay. So what is the summary statistics that we see? I see there are 392 values, and of course there are 392 values. Why? How do you know that? Because we have already seen that the shape, from the shape parameter here, there are 392 rows after dropping any missing entries. So that means there are altogether 392 horsepower. The mean value, the average value, কত পেয়েছি? What's the mean horsepower value? 104. ঠিক আছে? Is it clear নাকি না? Is that okay?
Yes,
Can you
sir.
see that? And the standard deviation of this is 38.49. তার মানে হচ্ছে basically what it means is, if I can write side by side, mean is 392. So the mean horsepower that we're getting is, let me just write 392. Plus or minus, the standard deviation is how much? Sorry, mean is not 392, I'm sorry. 104, right? 104.47, let's say. Plus or minus, standard deviation is how much? 38.5. Let me write it down as 38.5, right? Clear? That's the standard deviation. So this is the average horsepower that we see, right? And, okay, so the average horsepower is this. And you see that the average horsepower is 103 bolchi, which is somewhere here, 103. This is the average horsepower, right? আমি এখানে কি পাচ্ছি? What is this one? This is the most frequent one. ঠিক আছে? আচ্ছা, তাহলে আমরা একটা কাজ করি. What about আমরা যদি maximum and minimum দেখি, what's the minimum horsepower we could have? 46. We can see here. This is the minimum horsepower, 46. Okay, maximum horsepower is 230, which is here. 230 actually, এখানে কোথায়? এখানে তো 0 হয়ে গেছে. 230 is somewhere here. That's the maximum horsepower, right? আচ্ছা, 25%. If you find that the quartiles, so first 25%, 75 is the horsepower. 50% is 93.5. 75% is 126. Okay, now 50% মানে কি? এটা আমি ডেটা সেটটাকে ধরে, এটা মানে হচ্ছে আমি যদি ডেটা সেটটাকে ধরে 4 ভাগে ভাগ করি, I divide the data set into 4 parts. Okay, so the first 25% এখানে, okay, 25% data part গুলোকে সাজাই যদি 25% of the data cover করলাম, so this is the value of the horsepower we have got. That's 75, right? Okay, 50% is how much? 93. Okay, 93 would be let's say here. This is where the 50% data is. Okay, 93. 75% of the data হচ্ছে 126, so 75% data হচ্ছে 76. Sorry, 76 now, 126 is the value, right? Okay, and then on that side we have something. So a 50% মানে কি? What is this? Can you tell me? This is the median. This is the median. Median value মানে কি? Middle value. That means when you've seen halfway. So that's the 50%. Clear? We're going to talk about this distribution later on, don't worry. But basically 50% here is the median value, which is 93.5. So if we look at halfway, okay, if we take the entire data, if we look at halfway, 93.5, which is somewhere here. very close to this value. So this is the estimated median value. You can figure this out. Okay, remember this is an estimated plot, KDE, kernel density estimation. মোটামুটি জিনিসগুলো কি ক্লিয়ার হচ্ছে নাকি না? এই জিনিসগুলো নাকি না? Is this things okay?
Yes, sir.
Yeah. So did you get this summary statistics? So I actually plotted a summary statistics for horsepower. So we can see this one, and we can see that if we can relate this one or not. ঠিক আছে? Okay. আচ্ছা, আমরা আরো দেখব, অসুবিধা নেই। ঠিক আছে? Okay. Now, এই horsepower যে গ্রাফটা আমরা এঁকেছি, now there are two parameters that we have just used. Actually, in fact, I just have mentioned there which মানে যেটা ডিস্ট্রিবিউশন আছে, কোনটা ডিস্ট্রিবিউশন আছে, horsepower distribution আছে, and you should take the horsepower from the data frame called cars. Clear নাকি না? Now there might be other parameters here যেগুলোকে আমরা tweak করতে পারি, and we can play with that, and we can see different kinds of things. So let's have a look. One of the good ways to do that is এই parameters যেখানে রাখা হচ্ছে, put your cursor over here and then press shift and tab. Once you press shift and tab, you can click on this. Okay, so you can see different kinds of parameters that you have. One good thing is actually take it into the new tab. Okay, let's look at this. So whenever you are using a KDE plot, আমরা একটা Excel value দিয়েছি, Excel value হচ্ছে x axis রাখছি, so এটা কোথায় আছে? Okay, and there are other things as well, right? নাকি না? Do you see that নাকি না? Okay, এই যে দেখেন kernel আসছে, can you see that kernel? Right? Yes?
Yes, sir.
কার্নেল নামের একটা প্যারামিটার আছে, আমরা কিন্তু এখানে কার্নেল লিখিনি। আচ্ছা, আমরা যদি দেখতে চাই এই যে কার্নেল প্যারামিটারস আছে, এই কার্নেল প্যারামিটারস অ্যাকচুয়ালি what are the different values we have. So kernel parameters, it takes a string, well, it's a Gaussian, কি kernel and all these things. আচ্ছা, মজার ব্যাপার হচ্ছে যেহেতু if you have lots of data points, I have mentioned you, if you have lots of data points, it really doesn't matter what kind of kernel you use, you get almost similar distribution. মনে আছে একটু আগে বলেছিলাম আমি নাকি না? Yeah, so it doesn't matter whether you use a triangular kernel or use a Gaussian kernel or whatever. যেহেতু if you take lots of data points, okay, you get similar distribution. তার জন্য Seaborn 0.11.0 version থেকে, what they have done is they have deprecated other kernel কি বলে অন্যান্য kernel যেগুলো ইউজ করতে পারে সেগুলোকে deprecate করে দিয়েছে. They just use support for non-Gaussian kernels have been removed. তার মানে by default, what is the kernel that we are using therefore? Gaussian kernel, that's correct. So we are using a Gaussian kernel. এগুলো একটু জানার ব্যাপার আছে, because তুমি একটা KDE plot draw করলা, but when you're writing in a report, maybe it's a good way to say that figure 1 shows the KDE plot with the Gaussian kernel. So you need to know these details that's happening over here. Is that clear নাকি না? Are we good? So far so good নাকি না? Happy? Is that okay so far? ঠিক আছে? আচ্ছা, ব্যান্ডউইথ বলে একটা প্যারামিটার আছে, এটাকেও ডেপ্রিকেট করে দিচ্ছে। সো আমি আর ব্যান্ডউইথ নিয়ে we have discussions on bandwidth over here, but I have ignored that one, so we don't want to go. First of all, statistics এত কনসেপ্ট করার দরকার নেই, বাট ব্যান্ডউইথের একটা কনসেপ্ট আছে যে আমি এই যে উইথটা যতটুকু নিচ্ছি সেটাকে আমি চেঞ্জ করতে পারি, ঠিক আছে? বাট এটা নিয়ে আমার চিন্তা করতে হবে না। দিস ইজ কল্ড দ্য স্মুথিং প্যারামিটার, বিকজ এটাকেও ডেপ্রিকেট করে দেওয়া হয়েছে, ঠিক আছে? Okay, so it adjusts something in some way. You can see there are other methods as well, so we'll just use the default ones. ঠিক আছে? Okay. আচ্ছা, what other parameters do we have that we can play with? আচ্ছা, কিছু parameters আছে এখানে যেগুলো ইউজ করে we can actually improve the aesthetics or the looks of this plot. ঠিক আছে? আচ্ছা, now let's have a look at some of these parameters. And one of the parameters that you can look into is there is a parameter called shade. Now let's have a look. Shade. Now can you see a parameter called shade here, somewhere here? There must be a parameter called shade. Okay, shade. Can you see that? Shade. Yeah, that's right. So if we go here and let me search shade, okay, here is a shade. Shade, what kind of values does it take? What kind of values? It's a Boolean value. So Boolean value যদি নেই shade, ঠিক আছে, আর এটা একটা alias আছে, this is called fill, so you can use fill as well. Actually fill is recommended, but you can use the shade as well. So it has an alias one. Alias মানে কি? It does the same thing, correct নাকি না? Clear? Is that okay নাকি না? Yes? Hello? Are we good?
Yes.
আচ্ছা আচ্ছা, so এখন by default the shade value was false, ঠিক আছে, shade was false. Now what I've done here, I put shade equals to true. Now if I put shade equals to true, all that it does is it plots the graph and it's going to just shade it. That's it. It's just something that it looks a little bit different from that. So if you prefer this graph, if this graph looks interesting for you, just you can use this one. Is that clear nakina? Yes? Okay, so this is just to improve the aesthetics of that. Acha aro kichu ache ami jani na, there's something called vertical equals to false ache. So the vertical is a parameter, the default value is false. আমরা একটু ট্রাই করে দেখতে পারি vertical equals to true হলে কেমন চেহারা দেখাবে, ঠিক আছে, let's have a look, ঠিক আছে. So you go, so this is what I'm just trying to say over here, sorry, this is what I'm trying to say over here. Yeah, you can play with different parameters. Look at the documentation, look at what are the different parameters. Shop parameters niye ashole we don't need to use that, but there's a lot of functionalities, and sometimes it happens that some of these parameters you may find more interesting, ঠিক আছে, okay, or more useful, okay, all right. So that's the thing, ঠিক আছে. এই যে আমি আপনাদেরকে যেগুলো দেখাচ্ছি, যেসব প্যারামিটার নিয়ে আমি আপনাদের দেখাচ্ছি, these are the parameters I figured out for myself to be useful. And you can develop certain aesthetics as well, তাই না নাকি না? So let's say vertical টা কেমন হয়, okay, let's see. Okay, shift enter. আচ্ছা, let's create a cell here. আমি একটা কাজ করি, let's take this entire thing, copy, paste, okay. Our vertical default value কি false, আমি এটাকে যদি true করে দেই, I just want to see how does it look like, ঠিক আছে. So we'll try this one. So we're gonna do vertical equals to true. Remember, true by false, first letter ta, first character ta capital letter hota hobe, ঠিক আছে, true. Okay, what happened now? What kind of graph did it appear to?
So it changed the axes.
It changed the orientation. Axis change koreni, orientation change korche. Axis na, horsepower is on the y axis now, ঠিক আছে. It just changed the orientation, ঠিক আছে. So sometimes now একটা রিপোর্ট লিখবে, মেবি তোমার এইভাবে দেখতে যদি সুবিধা হয় কোনো কারণে, for some reason you can do that as well. Now এখানে একটা ছোট একটা ওয়ার্নিং আসছে. What is the warning called? The warning say that the vertical parameter that we have just used is deprecated, ঠিক আছে. It's just a warning, it's deprecated, ঠিক আছে. এই যে পার্টিকুলার ভার্সনটা আমি ইউজ করছি, এটা যদি ডেপ্রিকেট করা আছে, that means they're not using it. কিন্তু আমার কাছে আরো একটা আছে, you can actually assign the data to y variable instead. So আমি যদি এটা না করে ডেটাটাকে যদি y variable instead রাখি, I will have similar effect. What does that mean? তার মানে হচ্ছে আমার এটাকে নিয়ে আসলে instead of putting verticals equals to true, আমি x equals to horsepower না দিয়ে horsepowerটাকে y axis এ plot করলাম. Now it's the same graph that you get, ঠিক আছে. So they have similar effects. Am I clear নাকি না? Is that okay নাকি না? Got it?
Yes.
Yes, sir.
Good. Okay, very good, fantastic. Now the next thing that we are going to look at is something called cumulative distribution. Sir, আপনারা কি cumulative distribution কখনো করেছেন statistics এ? Have you guys done cumulative distribution in statistics?
Yes, sir.
CDF, cumulative distribution, yeah, করেছেন না? হ্যাঁ, মনে আছে? What does cumulative distribution mean? Do you remember what's a cumulative distribution? বুঝে গেছেন? হবে? আচ্ছা, let me show you very quickly, ঠিক আছে? Okay. Okay. Now, let's have a look. Here. Let's take, delete that. Okay, let's take an example. Okay, so let's say we have got some data here, which are like, I don't know, 0, 0, 1 2 3 3 কয়টা ডেটা পয়েন্ট 1 2 3 4 5 6 রাইট 3 আরেকটা নেই 7 4 4 5 দেখুন তো কয়টা ডেটা পয়েন্ট এখানে 1 2 3 4 5 6 7 8 9 10 okay how many data points we have
10.
10 data point এখন এটা যদি ডিস্ট্রিবিউশন আমি ড্র করতে চাই now I can actually have many ways to draw distribution. I can draw a frequency distribution. I can draw, of course, I can use KDE plot as well to estimate the distribution. Okay, but maybe because we have a small data points, when a KDE plot, I mean, frequency distribution to the height. Take it. So if we are drawing a frequency distribution, how does it look like? Okay, so আমি histogram আঁকি. Let's just draw histograms or histograms per bar. Okay. So what are the data points we have? We have got zeros. Let's see, 0 আছে, কি আছে আর 1 আছে আর কি আছে? Help me out. 2 3 equidistant হওয়া উচিত ছিল, যাই হোক 4 and 5. Correct নাকি না? Is that okay? আচ্ছা 0 কয়টা আছে?
2, sir.
দুইটা. So I can draw this 0. আচ্ছা আমি হিস্টোগ্রামই আঁকি 0 যদি এরকম করি দুইটা 2 1 কাটা আছে একটা 1 হচ্ছে একটা সো 2 এর অর্থ কত হচ্ছে এবার একটা 2 আছে কয়টা একটা 2 হচ্ছে একটা 3 আছে কয়টা তিনটা তিনটা হলে somewhere here তিনটা কারেক্ট আচ্ছা 4 আছে কয়টা দুইটা মেবি 4 দুইটা আর 5 কাটা আছে 5 হচ্ছে একটা আচ্ছা সরি একটা so something like that I can draw something like this okay maybe এখানে 1 না রেখে 1 টা মাঝখানে রাখা উচিত ছিল রাইট 2 মাঝখানে 3 মাঝখানে 4 মাঝখানে 5 মাঝখানে correct নাকি না something like that yeah we can do something like that আচ্ছা 0 1 2 3 4 5 right anyway but is it okay নাকি না so far yes
Yes, sir.
আমি যদি cumulative distribution draw করতে চাই now think about this what I'm going to do I'm not going to draw this. This is not cumulative distribution. Cumulative distribution means what is the total you have seen so far. Okay. Let me explain what does that mean. So if I'm drawing a cumulative distribution, let me show you. So we have again 0. 0 quite acha mithya akhi 0 ধরেন এখানে 0 আছে so it's easy to see 1 এখানে 2 এখানে 3 এখানে 4 এখানে 5 এখানে 0 কয়টা আছে how many zeros are there দুইটা so দুইটা out of how many data points
Out of 10, sir.
10 তার মানে 20% হচ্ছে 0 তাহলে I'm seeing 20% 20% means 0.2 correct নাকি না আচ্ছা now 1 কয়টা আছে একটা তাহলে 1 যদি একটা থাকে তার মানে 1 একটা রাইট নাকি না 1 একটা মানে হচ্ছে তার মানে we are seeing এইখান থেকে 0 20% দেখলাম তারপর 1 এ কি একটা হতে আমি যদি so far add করি তাহলে 20% আর 1 হচ্ছে একটা হচ্ছে 10% তাহলে all together 30% of the data দেখে পেলাম রাইট নাকি না so far we have covered 30% data up to this yes নাকি না yes আচ্ছা
Yes, sir.
2 কয়টা একটা মানে আরো 10% তার মানে আরো 10% অ্যাড হলে 2 সময় গিয়ে 10% অ্যাড হলো so that is 40% of the data cover করলাম 3 কয়টা তিনটা মানে কত পার্সেন্ট 30% তার মানে এখানে গিয়ে আরো 30% যদি অ্যাড হয় তাহলে এটা কত 70% correct 70% of the data right নাকি না তারপর 4 এ গিয়ে দুটো তাহলে 4 এ গিয়ে দুটো হলে আরো 20% অ্যাড হচ্ছে তাহলে কয়টা 90% of the data দেখে ফেলাম and last year 5 এ গিয়ে আরবার একটা তাহলে I'm going to have how much 100% so I've covered the 100% so this shows how the frequency is growing so this is a cumulative frequency distribution is that clear nakena yes
Yes, sir.
আচ্ছা সো এই গ্রাফটা একটু স্টেপ গ্রাফ পাচ্ছি মোটামুটি, কারণ দিস ইজ মোর লাইক ডিসক্রিট, তাই না? কন্টিনিউয়াস হলে গ্রাফটা স্টেপ না হয় একটু মোর কন্টিনিউয়াস গ্রাফ হতো, উইল সি দ্যাট, ঠিক আছে? বাট so far did you understand what's the cumulative distribution? Yes নাকি না?
Yes, sir.
So finally লাস্ট পর্যন্ত কত পার্সেন্ট ডেটা দেখলাম করে টু কভার করলে 100% ডেটাই কভার করা হবে। Am I clear নাকি না? Is that okay? Yes?
Yes, sir.
Okay.
Yes, sir.
So আমি যদি এখন এই যে ফ্রিকোয়েন্সিতে কার্নেল ডেন্সিটি এস্টিমেশন যে ডিস্ট্রিবিউশনটা আমি এস্টিমেট করছি, if I want to see what's the cumulative distribution of that, what would be the cumulative distribution graph of that, I can actually do that. How is that? You'll see that এখানে একটা প্যারামিটার আছে called cumulative. Can you see that নাকি না? Yeah, in the KDE plot you have a parameter called cumulative, correct নাকি না? Yes, hello.
Yes.
এই cumulative plotটা initialize করা কি থাকে as false.
False.
The default value is false. Now if I make it true, what happens now? If I make it true, now look at this. So same thing, sns.kde plot, x-axis এ horsepower রাখছি, এখন orientation change করিনি, x-axis এ horsepower, and this data is taken from a data frame called cars, and the only thing I'm changing is cumulative is equal to true. If I do so, if I say cumulative equals to true, if I run this one, you see that this is a kind of graph that we have. Clear নাকি না? And in fact, if you look at over here, graphটা almost একই ধরনেরই না? আমি যদি কন্টিনিউয়াস ইয়েতে আঁকি তাহলে আনটা একই ধরনের না, এরকম হবে না? Yes?
Yes, sir.
S-shaped nature গ্রাফটা হয়, ঠিক আছে? Of course, S টা কিরকম বেন্ড হবে depends on the data, ঠিক আছে? So you can see we actually end up getting a cumulative data distribution of this graph, ঠিক আছে? Estimated cumulative distribution. Clear? Is that okay নাকি না? Are we good? Hello, ঠিক আছে? এগুলো তো আপনারা স্ট্যাটিস্টিক্স পড়ছেন তাই না? Cumulative distribution graph, frequency distribution graph, right নাকি না? All I'm doing is I'm just showing all these things that we can do, right? Okay, and it tells us different things. So again দেখেন মজার জিনিস, if we look at this one, finally how much data we have seen so far?
100%.
Right, that's exactly what we were saying. You have covered 100% of the data. আচ্ছা, আমি যদি হিস্টোগ্রামে করি তাহলে হিস্টোগ্রামে these are the densities, right নাকি না? Yeah, what is the total area under the graph? 100%. Is that clear নাকি না? এরিয়া কত হবে? ফ্রিকোয়েন্সি ডিস্ট্রিবিউশনে এরিয়া কি হয়? Total area is the total amount of data, 100%. Am I clear নাকি না? Is that okay? ঠিক আছে? আচ্ছা, এটার এরিয়া হচ্ছে 1 বা 100%, আর কিউমুলেটিভ ডিস্ট্রিবিউশনে ফাইনালি এটা হচ্ছে 100% কভার করা। Is that okay to everybody নাকি না? Is that fine? এগুলো ঠিক আছে নাকি না? এগুলোতে ভুলভাল আছে, সমস্যা হচ্ছে কোথাও? Are we good? Hello?
জি স্যার।
প্রবলেম হলে বলেন, এখনই বলেন যে এটা বুঝতে অসুবিধা হচ্ছে, প্রবলেম হলে বলেন। কোথাও প্রবলেম আছে কারো নাকি না? Is it okay?
Okay.
Okay, acha. Now let's look into a different kind of aesthetics. Now there is another thing that we have is something called color. There's a parameter called color, so we can change the color. So if we look at this one, color, so let's color. Okay, yeah, I'm color variable. Okay, here is the color variable. Okay, so matplotlib.color se gele ami ashole koto dhoroner color use korte pare, we can see that. Okay, so we can change the color of that. So if we want to play with the colors as well, we can do that. So I'm taking the same graph. So x hai horsepower, data ta cars theke cumulative true, so it's a cumulative distribution. Our color kochi red. So if we color this one red instead of the default color that it has chosen here is blue, if we do that, now you see you get a graph like that way. Maybe you may like this graph, so if you like this graph, that's fine. Okay, আমরা যদি এখানে colors change করি, what happens if I change the color here? Color equals to red করি কি হবে? Color equals to red. Okay, the string, so I put it in a string. So let's see what's going to happen. It changes the aesthetics of that. Is that okay, Nakina? Clear? Yes? Then you can actually play with this one, two different kinds of things, and start doing that. This is rubbish. Doesn't look very good. So we can do different things. Okay, yeah. Okay, so it finds a black color and it shades in a little bit darker mode. Okay, anyway, so you can play with that. And actually that will determine how it looks like. Is that okay so far, so good, Nakina? Yes? Okay. So far, so good. Acha. Now, a cars নামে যে data set আছে সেই data set এ কি columns আছে? These are the columns. These are the 9 columns we have. Okay? আচ্ছা। আবার বসে না দেখে আমরা একটা কাজ করি। আমি just I wrote cars.columns, print cars.columns. So it prints out all the columns that this particular data frame has. These are the 9 columns it has, MPG, cylinders, and stuff like that. Now let's say we are plotting a different graph. So let's say I want to plot a scatter plot. Scatter plot মানে কি? Can anyone tell me? Anyone? Scatter plot মানে কি?
Sir, not arranged. Sir, is
Not arranged. কি বলে? Not arranged মানে কি? Scatter plot means, let's say if you have some data points, let's say for example we have data points x and y. Okay, x is 0, y is 1, x is 1, y is 2.
data point গুলো দেখাবে আর কি।
Yeah, you just draw the points, and so x is 0, y is 1, x is 1, y is 2. You just draw the points. You don't draw any lines. So that's what we do using something called a scatter plot. So we can use something called a scatter plot. But if you want to draw a line, maybe Seaborn, there is something called a line plot. Just have a look. Always try different things. So I'll just search Seaborn line plot. You see, automatically, and it's called line plot. So that can Seaborn scatter plot যদি draw করি, okay? X হচ্ছে horsepower, x-axis এ horsepower, y-axis এ কি রাখছি? Miles per gallon. এবং দুটো ডেটাই আসছে from where? From the data frame called cars. Is that okay, Nakina? Yes? Hello?
Yes, sir.
Acha. So that's what it is, and because I drew a scatter plot, that's the kind of scatter plot we have. Now, if instead of scatter plot, if I said line plot, I don't know how it would look like. This might look a little weird. So let's see, line plot. Okay, so that's the kind of line plot that it has. Okay, right. So just joins all the lines. I think a scatter plot is a better plot, but there's another plot for red plot. red plot পরে যায়, এটা এখন কথা নেই. Let's look at the scatter plot. So we drew the scatter plot. So we look at this one. কিন্তু আমরা একটু আগে KD plot নিয়ে কথা বলছিলাম, right? We were talking about KD plot, and we were talking about KD plot for univariate KD plot. Univariate KD plot মানে কি? What is univariate KD plot মানে? What does univariate mean?
one variable.
Unique
For one variable. What is the variable for which we drew this KD plot?
Horsepower.
Only for horsepower. We did not do for 2 KD plots. We did not do for 2 variables. But it turns out that we can actually do for 2 variables as well. So here's an example of a bivariate KD plot. So actually, let me write a comment over here. Let's say, I'll write it down here. Bivariate KD plot. ঠিক আছে? আপনার ইয়াতে কি বলে Jupyter Notebook যে শুধুমাত্র যে কোডই লেখা তা না। if I want, I can write some comments as well. So I'll put this as a heading, not a code. So you would say this is yes and run that. So this is the bivariate KD plot. ঠিক আছে? So let's see what's the bivariate KD plot here. So how do you do that? Same sns.kd plot. X-axis এ কি প্লট করছি? Horsepower. আর y-axis এ কি প্লট করছি? Miles per gallon. And the data is taken from cars. Now, if you do that, you get a weird looking graph like this. So this is the density, it's a KD plot for horsepower and MPG. So if you see, compare the scatter plot with this one, you would see যেসব জায়গায় আমার বেশি আছে ডেটা পয়েন্টস গুলো আছে সেই সব জায়গায় ইউ উইল সি আ লট অফ রিংস ওভার হিয়ার রিংস গুলো যত ডেন্স রিংস দ্যাট মিনস देयर আর মোর ডেটা পয়েন্টস ওভার देयर মাঝখানে এখানে দেখা যাচ্ছে রিংস একটু কম ঠিক আছে অলরাইট ওকে and you will see over here okay somewhere here that like অল্প একটু differences আছে ঠিক আছে okay and এখানে ডেনসিটি একটু কমে আসছে তো এখানে রিংস এর সংখ্যা কমে আসবে বা it looks like that so you can do different kinds of things so this is like a bivariate KD plot ঠিক আছে okay right okay so there are other things that you can do but I find univariate KD plot very useful for me ঠিক আছে because it tells me kind of distribution that we have ঠিক আছে for this particular one okay then আমরা এটাকে নিয়ে আরো অনেক ইন্টারেস্টিং কাজ করতে পারি ঠিক আছে okay now if you look at over here আচ্ছা KD plot দিচ্ছি there is something called hue বলে একটা প্যারামিটার আছে hue ঠিক আছে hue বলে প্যারামিটারটা is a very interesting parameter and I'll be using this hue parameter in lots of plots ঠিক আছে okay so let me show you what happens here আচ্ছা সিলিন্ডার্স কয় ধরনের সিলিন্ডার্স আছে জানেন এই গাড়িতে কয় ধরনের সিলিন্ডার্স ইউজ করছে রিমেম্বার how many kinds of cylinders are there বলুন কয়টা এই যে সিলিন্ডার্স 4 8 6 3 5 আচ্ছা নাও আমি দেখছি 4 8 6 এখানে ম্যাক্সিমাম আছে তাই না 199 199 108 up 3 and 83 ঠিক আছে 3 and 5 এ খুব কম আছে so I can actually if I like I can actually ignore that ঠিক আছে because it's so small ঠিক আছে but in any case just to make things much more simpler what I'm going to do right now is I am going to now change it a little bit I'm going to say cars.cylinder এর মধ্যে is in 4 and 8 তার মানে if the cylinder values are 4 and 8 শুধু সেগুলাই শুধু নিয়ে এই ডেটা ফ্রেমে এখন আপলোড করো ঠিক আছে তার মানে অন্যান্য সিলিন্ডার ভ্যালু যদি থাকে লাইক সে ফর এক্সাম্পল আর কি আছে 5 আছে আর সাম আদার সিলিন্ডার্স আছে ওগুলোকে আমি ইগনোর করছি সো আই এম রিডিউসিং দ্য ডেটা সেট ঠিক আছে নাকি না সো নাও দ্য ডেটা সেট হ্যাজ হাউ মেনি সিলিন্ডার্স 4 and 8 cylinders correct নাকি না ক্লিয়ার ইয়েস বুঝতে পারছি so we're looking at this specific মানে subset of the data set right now ঠিক আছে okay are we good
Yes, sir.
আচ্ছা now দেখেন আমি কি করছি if I plot a graph sns.kd plot x axis হচ্ছে হর্স পাওয়ার y axis হচ্ছে miles per gallon এবং hue কি দিচ্ছি what is the hue
সিলিন্ডার
হ্যাঁ এই হিউ যে ভ্যালুটা আছে এটা সব সময় ক্যাটাগরিক্যাল ভ্যালু হতে পারে ক্যাটাগরিক্যাল বা ডিসক্রিট ভ্যালু সো এখন হিউ সিলিন্ডার্স ইজ এ ক্যাটাগরিক্যাল ভ্যালুজ কারণ সিলিন্ডার্স ক্যান বি 4 or 8 তাই না নাকি না ইয়েস ক্লিয়ার
Yes, sir.
okay and data is cars now let's say আমি হিউটা যদি না দেখি হয় আগে দেখি পরে হিউটা দেখব ঠিক আছে so if I don't draw the hue let's plot this so that's a graph horsepower on the x-axis y-axis এ miles per gallon now আমি এখন এটাকে ডিভাইড করতে চাই using a hue parameter hue can be a মানে categorical variable and cylinders is a categorical variable I'll just put cylinders as a hue okay we'll come over there and then run that now you say that cylinders can be 4 or 8 4 cylinders হলে শুধু 4 cylinders বিশিষ্ট গাড়ি যেগুলো সেগুলোর ডিস্ট্রিবিউশনটা is drawn over here that's bivariate is there আর 8 cylinder বিশিষ্ট যেসব গাড়িগুলো আছে সেটার bivariate distribution is actually here can you see that নাকি না so even if you want to know যে আচ্ছা cylinders changes এর সাথে কি distribution এ কোনো changes আছে নাকি I can do that can you see that নাকি না we can do that clear is that okay
Yes, sir.
right now এখান থেকে আমি কি বের করতে পারি বলেন তো cylinders 8 cylinders সেগুলা কি হর্স পাওয়ার কি বেশি না কম
বেশি স্যার
বেশি and miles per gallon
কম
কম ঠিক আছে so miles per gallon কম কিন্তু হর্স পাওয়ার বেশি আর 4 cylinders সেগুলো হর্স পাওয়ার কম miles per gallon বেশি ঠিক আছে is this clear নাকি না yeah so we can see we can interpret lots of things from this visualization a visualization করাই হচ্ছে to actually interpret. ঠিক আছে? Is this clear নাকি না? Yes?
Yes.
Okay? আচ্ছা। Now, more on aesthetics, there is something called palette. Palette, এগুলো অনেক ধরনের palette আছে। আমি পরে I'll give you a link to this palette. So এখানে আমি palette use করছি PIYG. So there are other palettes as well. So এটা যেটা করে, it's a colors and aesthetics গুলো শুধু change করে। ঠিক আছে? Okay? So we'll talk about these palettes later on as well. So let's not worry about it today. ঠিক আছে? Is it okay so far? Clear?
Yes, sir.
Yes? আচ্ছা। So far what we have seen today, আজকে কি দেখলাম? আজকে দেখলাম যে we can use, we can draw different kinds of plots using Seaborn and Matplotlib. We have seen that Seaborn can update the RC parameters or run command parameters of the Matplotlib library. And then we have seen that I can use this Seaborn to do different kinds of plots. Of course, we haven't done all kinds of plots today. We've just seen one kind of plot today, which is the KDE plot, right? Nakina, that's what we have seen. Okay? So KDE plot, the key, we have seen the background of KDE plot, and we have seen how to plot a KDE plot graph using the Seaborn library, and how to interpret from the KDE plot. So we have seen frequency distribution graph, we have seen the cumulative distribution graph and stuff like that. Is that okay, Nakina? Clear? Yes?
Yes, sir.
In the next couple of classes, we're going to see some more plots. Okay? And we're going to also build up an intuition of যে কখন কোন প্লটটা is suitable. Suitable কেন? প্লট কিন্তু কেন করি? এমনি করি না। প্লট করি to understand the data set, to interpret the data set. এই যে এখানে যে আমরা একটা প্লট করলাম, প্লট করে যে লাস্ট প্লটটা যেটা আছে, হ্যাঁ, we see certain interesting thing. Okay, first of all, যখন আমাদের এমনি হিউ না দিয়ে করলাম, we saw the distribution. But then আমরা হিউ cylinders এ যদি ভাগ করে নেই, we can say, okay, now fine, there's a distribution there, but cylinders এর value উপর the distribution changes as well. Can you see that, Nakina? And we have seen that, okay, cars with high cylinders will have high horsepowers but lower miles per gallon. That's what we can see, right, Nakina? Is that clear, Nakina? Yeah. So the whole point is, once you have a data set, it's a very good thing to actually understand the data set before starting doing any kind of machine learning on that. Okay? Understanding the data set is extremely important. Okay, and so for that reason, we are going to, in the next few classes, we're going to do different kinds of distribution graphs, different kinds of plots. And the whole point of plotting is not to just plot, but to interpret what does it tell about the data set. Okay, right? Achha. So I think we're going to stop over here. If anyone has a question, I'll be happy to answer that. Otherwise, we can stop the recording for this lecture. Does anyone have any questions related to this course, related to this lecture today? No? Okay. So if not, I'll stop the recording.
Sir,